So this is the opposite of synthesis reactions. What I have here is I found a little picture of an iron ore mine, and you can see all this brown rock and the whole thing. What that actually has in is a lot of this brownish colored rock. That's called iron ore. And there are places on the planet where iron ore is really rich in the iron content. And this iron ore is going to be a large percentage of iron oxide and iron 3 oxide. And in really good mines, this will be about 50% of this rock. The other 50% of the rock is going to be other minerals which have different formulas, and it could be magnesium oxide or sodium chloride or any other kinds of salts that are in the rock, and we're going to ignore those for now. In iron ore, what you mostly have is iron oxides of these two types. Now, if we heat that really, really hot, what we can do is decompose. We can split the two elements. And for those of you who are thinking, yeah, but this goes against the second law of nature, it's like, yeah, we have to put energy in, okay? We have to put the energy in here as heat to separate the iron from the oxygen to get the iron and the O2. And that's a really big key here when you do decomposition reactions, is you have to realize that the oxygen is going to be paired. It's one of the diatomic gases. All right, and you're going to separate these two elements. And having done this, there's our separation. But now, the first law of thermodynamics, for those of you who are concerned, and you should all be concerned, is how did we get 2 oxygen atoms when we only started with 1? Well, that's where we have to start balancing our chemical reactions to make sure that the first law of thermodynamics is applied. And it's pretty simple to do here. This oxygen really looks like this, right? They're sharing it. This iron is by itself, okay? And in this case, it had 2 lone electrons. This, and I'm going to erase my arrow and go, this is really bonded as follows. They're sharing 2 electrons like that, right? Well, we need to put a coefficient in front, it's called. I'm going to make it blue and say we need 2 of these. So that means we're going to have a second one like this. So there appears our second oxygen. So in the rock over here, there's actually gazillions and gazillions and gazillions of these FeOs. So to balance our reaction, we actually have 2 of these. Okay, we have 2 of these reacting, and one is going to produce this oxygen, the other is going to produce this oxygen, and now you can see we actually have, we need a coefficient to say we have 2 of these irons are produced like this. So we need to put a 2 in front. So now we have 2 iron, 2 oxygen, see, 1, 2, and we have 2 oxygen. Okay, so that's nicely balanced. So that's an example of a decomposition, and we threw some balancing in there. Bye-bye.